Okay, let's go ahead and get started. Thank you, sir. All right, so I'm Travis Wright. I'm one of the PMs on the SQL Server engineering team. And we have been working on putting together this SQL Server 2019 big data clusters for the last about a year or so. And we just announced that this week. Everybody heard about the announcement, I'm guessing. That's why you're here, right? So what do you guys think? Is it pretty exciting? Don't know, not sure? Like, what the heck? What's Spark? How many? It's like all new, right? Some people. So today we'll just give you kind of an overview of what we're doing and why we did it and that kind of thing to just kind of give you guys an idea of where we're headed and what we're thinking about this. And then we're just very interested in getting your feedback on what we're doing and whether or not we're heading in the right direction here. So basically what it comes down to is that the amount of data that people are managing is just exploding. It's pretty crazy. Like, one of the stats I like to throw out is that, I don't know, somebody went out there and counted all of the bits and bytes in the world, and they figured out that 80% of the data that is in the world today was generated in the last 2 years. I don't know who counted all that data. That's a lot of data. I don't know how they counted it. Sounds like an interview question if you ask me. Like, okay, estimate the amount of data in the world, and then like somebody has to figure it out on a whiteboard, right? But anyway, there's a lot of data out there. The types of data that we're storing is becoming more and more diverse as well. We have IoT data streams coming in. The volume of the data sets we're managing is just getting out of control. So really what we need to do, though, in order to drive the success of our organizations is to be able to get the insights out of that data. It was interesting, I was watching some like financial news channel on the TV this morning, and all these people were talking about, like, from one segment of the show to the next, was how these companies were gathering and using data. Like, they were talking about Amazon's new store, their new retail store that they have. And they were talking about how they think that, like, one of the main reasons why they have this retail store is that they can have people go into the retail store and they can collect data about the stuff that people buy in a retail store and how they move around the store and what types of people come there. And like, the whole point of the store isn't so much to sell stuff, it's just to gather data about people's buying behavior. You know, it's like everything ultimately like came down to data in some way in all these different news segments they were talking about. So one of the things we do every year is we go and we actually do a survey of a few hundred enterprises, and we find out how they are using technology. And then we go and compare that to the financial results that these publicly traded companies post. And we look for what are successful companies doing in terms of how they're using technology. And what are those companies doing differently than the rest? And in the last couple of years, we've seen a trend emerge where these companies are doing integration of their data without using ETL. And they are combining their data into centralized data stores to make that data more easily integratable and accessible. And they are doing predictive analytics on their data. So we look at these kind of trends and we say, okay, what can we do to help these enterprises be even more successful with SQL Server and help those companies that have maybe fallen behind the curve and aren't as successful because they're not doing these things, be able to do those things more easily. So SQL Server 2019 is really about enabling you to integrate all of your data and to manage all of your data and to analyze all of your data. And we'll cover those three things today. So first, let's start with integrating all of your data. In SQL Server 2016, we introduced a feature called Polybase. How many people here have heard of Polybase? Okay, how many people are using Polybase? Okay, that's what I expect, right? A few. And so what we did is we went and we talked to customers like, why are you using Polybase? What are the problems you're having with it? That kind of thing. And what we found was that people love the idea of Polybase, like, make it easy for me to integrate all my data together, but then we found some impediments to adoption. And we address those impediments as part of our solution here. And one of the things we're doing is we're taking that same concept of how Polybase works, because it makes it easier for people to integrate their data by creating an external table inside of SQL Server over some external data source like Oracle or Teradata, MongoDB, et cetera. And then you can just query that table inside of SQL Server just like you would any other table. You can join it to other tables. But at the time you query data out of that table, we go and actually get the data from the external data source. And so in 2016, we did this over like a Cloudera or Hortonworks HDFS. In 2019, we're now adding connectors to Oracle, Teradata, MongoDB, other SQL servers, and a generic ODBC connector you can use to connect to any data source that is ODBC compliant. And at the time you run the query, we'll go get the data. You don't have to necessarily move the data into SQL Server in order to be able to query it. Make sense? So one of the things we're going to do to improve the performance of these types of queries is we're introducing, as part of SQL Server 2019 Big Data Clusters, this feature called a data pool. And a data pool is a set of SQL Server instances that you deploy. And what we'll do is we'll go and you basically create an external table, and you say with data pool, and you point this to a data pool. And we'll go get the data from the source, like an external database, like Oracle, for example. And we'll then bring that data over to the data pool, partition it, and spread it across these multiple SQL Server instances. So now the data is partitioned across multiple SQL servers. And then we put column store on top of it automatically to make it super fast. And then when we go to do a query over that external table, instead of going back to the source and getting the data, we do a local filter and aggregation in parallel across all of these SQL Server instances. So you basically apply your where clause in each of those partitions and then send back the summary of the results to the master instance of SQL Server. So let's take a look at a demo of creating an external table over Oracle. So here I am, I'm inside of Azure Data Studio. Hold on, I got to show you this. And Azure Data Studio is our new cross-OS, Windows, Linux, and Mac tool for people, for all kinds of people, for data scientists, for DBAs, for developers, and you'll see kind of some different experiences as we go through this today, where this is kind of a unified tool for all of your data, whether it's sitting inside of SQL Server or HDFS, or you want to use it with Spark. So to begin with, we're going to connect to this SQL Server right here, and we can kind of just browse around this SQL Server, much like we would in SQL Server Management Studio, for example, and we can see the tables and so on that exist inside of this sales database. And now we're going to use the new Create External Table wizard inside of Azure Data Studio to connect to an Oracle database and create an external table over a table inside of Oracle. So to do that, I'm just going to give this external data source a name, and then I'm going to connect to the server where this is at. And we'll connect to the XE database, and we're going to create an Oracle credential. And we're going to connect with the system and this super secret password that I can't tell you because it's so difficult. Okay, and now what we're doing is we can actually go out to that Oracle instance, and we can actually browse the schema that's available on that database, and we can choose the tables that we want to synchronize over as external tables inside of SQL Server. And we can even view the schema of those tables here and do column mapping if we wanted to create different column names, or maybe we want to change the name of the table inside of SQL Server. And then we can click Next and Create, and this will go and create a new external table for us. So if we now go over here and refresh the tables list, we'll see that we have this new Oracle inventory table, and we can just do a select top 1000 over this table, and at the time that we just do this query, we're going to go get the data out of the Oracle database and bring it back. So now all of your applications that are connecting to SQL Server now have access to all that data that exists in that table in Oracle, and it's all coming back in real time, essentially, whatever it is that's in Oracle, right? So this kind of solves the problem, like where with ETL, it's kind of a problem, right? Like ETL, first of all, I have to write some code to do that data synchronization. That would have taken me a lot longer than it took me to do that wizard, right? And then I would have had to maintain that ETL job over time as the schema changed or whatever. And I'm creating duplicate copies of my data. And every time I move that data, I'm moving it potentially in and out of compliance boundaries. I'm increasing my attack surface area for the bad guys by having copies of that data everywhere. And I also have to, kind of just constantly be maintaining this thing, right? And everybody, I'm sure you guys all have this. I call it ETL spaghetti. You guys have ETL spaghetti, where you just have jobs going all over the place, who knows where the data's at? Especially with like GDPR compliance, the user comes to you and says, hey, I want you to delete my data. You're like, oh, I don't even know where your data's at, sorry. It's all over the place, right? So with data virtualization, we can leave the data in place, yet still make it queryable from SQL Server, just like any other table. All right, so now let's take a look at kind of the next chapter here in managing all of your data. So in managing all of your data, what we want to do is we want to make it easy for people to integrate their big data and their relational data. So this is your relational data, this is your big data, they're in love, it's beautiful, it's a happy story. And that's kind of what we're trying to go for here, is that these two, like almost every customer I talk to The big data guys are off in one building, and the SQL guys are off in another building. And they rarely talk to each other except to figure out how to ETL their data one way or the other, right? That's the only thing they ever do is like, I want your data, I want your data. And all they do is figure out ETL jobs between the two, and they're exporting their data all over the place, right? So what we want to do is we want to create a unified system that allows you to deploy your relational data and your big data as one unified solution that's provided by Microsoft and supported by Microsoft. And to do this, we're actually taking the open source projects around big data, like Apache Spark and Apache HDFS, and we're putting them in the box with SQL Server 2019. So you deploy SQL plus big data as one solution on top of Kubernetes. How many of you guys are familiar with Kubernetes? Okay. Kubernetes kind of started out in the kind of application land, right, where things don't have to be stateful. You can lose your data, it's not a big deal. There's no data really, it's just all stateless, right? But now people are starting to, as this container ecosystem starts to mature, they're running database workloads on top of Kubernetes as well. And there's a lot of advantages to using Kubernetes for hosting this architecture. First of all, it's very fast to stand up containers. I did a demo, I'll post a video here pretty soon to YouTube, where on some HPE hardware that they provided to us in their lab, it's like 3.5 terabytes of RAM and like 800 cores or something. It's a pretty beefy system. And with a single command, I can stand up an entire SQL Server 2019 big data cluster with 300 instances of SQL Server, 200 HDFS data nodes, 200 Spark runtime instances, Yarn, Knox, Ranger, a full management plane with like Elasticsearch to store all the logs that are being collected across the whole thing, InfluxDB to store all the monitoring data, an admin portal, and so on and so on. Like all this stuff, I can deploy the whole thing with a single command, and all the images are downloaded, and all the containers come in up, and everything's automatically wired together, and you can connect to either the SQL endpoint or the Knox endpoint in 8 minutes. I don't think you can download the Windows ISO of SQL Server in 8 minutes. Just download, right? So it's pretty impressive what you can do because this architecture is based on Kubernetes. One of the other key benefits of being on Kubernetes is that it's an application abstraction hosting platform, right? So you can run a SQL Server 2019 big data cluster wherever you have Kubernetes. It could be a Kubernetes cluster you have in your own on-premises data center. It could be OpenShift in your on-premises data center. We demoed this week in a keynote running SQL Server 2019 big data clusters on top of Azure Kubernetes service on top of Azure Stack. Or you could run it in a managed Kubernetes service in Azure or in someplace like AWS, EC2 container service. It doesn't really matter. Kubernetes provides that abstraction for us, and we can deploy it wherever we want. Now, as part of this architecture, when we deploy HDFS, every HDFS data node will have a SQL Server engine running right next to it, and it'll have a Spark engine on it as well. And that allows us to access that shared data lake through either SQL Server or through a Spark job. So now, if your data scientists prefer working with Spark, great. They can use the Spark endpoint to connect to and do their Spark jobs over that shared data lake. Your application developers, your DBAs, those kind of guys, maybe they want to come in through the T-SQL interface and access that data. That's beautiful. Everybody can party on this one shared data lake. And so if you take a look at this architecture, what this kind of comes down to is that we deploy what we call a storage pool, and the storage pool is this combination of HDFS, Spark, and SQL together in a scalable architecture. So that over time, provided you have the underlying hardware capacity that's been joined into your Kubernetes cluster, you can keep just deploying additional storage pool pods to scale up your capacity for storage and for compute at that layer. And then you can run a query here inside of the SQL Server master instance and go and reach down to the SQL Server instance that's co-located on every HDFS data node. So if you want to read a single row out of a table here inside of a CSV file in HDFS, for example, you can create an external table over the top of this and read that data file. And what we do at that time is we actually send a query down to the SQL Server instance that's on the data node where that data file is at and say, read that CSV file or Parquet file. And SQL Server now has the ability to read and write those data files natively. And we're going to read that, okay? So let's take a look at a demo of doing this, actually. So I'm going to grab this query here. Oh, sorry, I got to get out of this. I always forget to do that. Okay. So let's grab this query here. go back over to our lovely Azure Data Studio, and we're going to create this new query. Do this. Okay, now you can see here that I'm going to create an external table over this directory that sits inside of HDFS. Now this is the HDFS browsing experience that you get inside of Azure Data Studio. It's basically just a file explorer experience built into Azure Data Studio where you can see everything that's going on inside of HDFS. And you can see that I have this directory here called clickstream data, and I have a CSV file inside of that contains millions of records of clickstream data. And so I can just create an external table over this directory, and I can say, use the SQL storage pool to do this type of query. And then I define a read schema, like an on-read schema, over that data file. So now I can just create this external table. And once I create that external table, I can now just query over that table just like I would any other table. And one of the interesting things about this particular query is not only am I reaching down and querying that data out of the CSV file sitting in HDFS from SQL Server, but I'm joining it with data that is running inside of the SQL Server master instance as well. So this allows me to combine together my OLTP data that's running on that master instance with my HDFS data in one query. I'm just joining tables. There's nothing special about it. Sorry, I've been talking a lot this week, as you can imagine. So let's keep going here. So now if we want to do a really big query, then we can introduce what we call a compute pool. And a compute pool is multiple SQL Server instances that are deployed as containers on top of Kubernetes. And they work together to ingest data from an external data source, like HDFS, for example. And each compute pool instance will pull in a partition of the data. And then the compute pool instances will talk to each other to do aggregations and shuffling across the entire data set, cross-partition aggregations and shuffling. And it'll send the results back to the head node. Thank you, Nelly. I think my team's just going to start following me around with the water bottle at this point. Like, this happens like every time, it seems like, at this point. So you can also put compute pools over external data sources like Oracle, Teradata, et cetera. And you can use the data pools that we talked about earlier, where you have the caching inside of the data pools, and then you put a compute pool on top of that. So then you're doing local filters and aggregations here, and you're doing cross-partition aggregations and shuffling here. So you have a scalable architecture now. So if you think about it, this is basically like, SQL Server has always been a scale-up system. If you want to process your queries faster, or you want to store and manage more data, you go to your favorite OEM and you buy a bigger box, right? With this architecture, you now have a scalable system where you can scale out the storage using HDFS. You can scale out the storage using the data pool instances. You can scale out the compute using the SQL Server instances in this layer. You have Spark that can scale out. You have compute pool instances that you can spin up and down on demand, so it's elastic. And you can even scale out the master instance by making this an always-on availability group, so you get read scale out with the read-only secondaries. So SQL Server has like really grown up. This is now like not just defined by a single box, right? This is something that you can now deploy on a massive architecture that's scalable and elastic. So we're going to provide a unified administration experience for this as well. So you've seen the Azure Data Studio tool that allows you to do SQL and HDFS, and we'll see here in a minute Spark as a single tool. We're providing a management service out of the box that does all of the log collection across the entire architecture and brings it back to Elasticsearch, and then we put Kibana on top of it so you can do log analytics. And we'll have a monitoring data collection agent that brings back monitoring data to InfluxDB. And then we have dashboards like you see here in this screen capture that allow you to monitor the performance of everything throughout the cluster. So let's now take a look at the analyzing all your data. So when it comes to analyzing all your data, what we provide here is a complete AI platform. Everything from ingesting your data through Spark streaming, for example, through landing and storing your data inside of HDFS or inside of the SQL Server master instance or the data pools. And then you can go on to do your data preparation tasks using Spark. You can do machine learning using either Spark ML or SQL Server machine learning services. And you can operationalize those models inside of SQL Server using the native T-SQL predict function, or you can operationalize them in containers that will help you create from your models, where we basically give you a toolkit. You take your model, we'll automatically wrap a REST API around it that's Swagger-based, and then automatically provision it for you as a container on top of Kubernetes. And because it's a Swagger-based REST API, you can auto-generate a client library for any programming languages you want. Java, C++, C#, doesn't matter. And now your application developers can easily operationalize that model using that client library and those containers running on top of there. So let's take a look at the notebook experience that is built into Azure Data Studio that allows you to create Spark jobs and run those against the Spark side of a SQL Server Big Data cluster. So to do that, I have a notebook here. And this notebook experience is brand new to Azure Data Studio. We just unveiled it this week as part of the SQL Server 2019 preview extension. And the notebook experience is kind of maybe new to people that are familiar with running T-SQL queries, right? So basically the notebook experience, the way it works is that you have these different cells that have code in them. And we're going to create a T-SQL style notebook experience here too. But inside of these code cells, you basically just have some code. In this case, it's Python that we're going to go and we're going to run this against the Spark runtime inside of the big data cluster. And I can run some code. In this case, what I'm doing is I'm loading up this CSV data file that exists over here in this directory. And then I'm just doing a data frame.show so we can see the data that exists in here. And this is just some sample data set of like a diabetes analysis where you can try to predict whether or not somebody will have diabetes based upon some of their bio data. And then we can create a view over that, for example. And then we can do some Spark SQL type queries where we can use SQL query syntax to query over that data as it sits inside of HDFS. So this is using Spark SQL. So we saw earlier about how to query data that sits in HDFS using T-SQL. Here we're doing a query using Spark SQL. And we can see here kind of the results. And we can see that there's not really a strong correlation between age and insulin level. So now let's apply machine learning to figure out this problem. So here we're doing featureization using Python to take the data set and featureize it into these different features that you see here. And now we can use the k-means algorithm to break this down into a clustered data set that we can then start to do predictions on. And down here we can do a prediction, and let's see if BMI or body mass index is a good predictor of whether or not someone will have diabetes. And you can see that, not surprisingly, because we know this based on science and stuff, and doctors telling us this, if your BMI is relatively high, around 35, you're more likely to have diabetes than somebody that has a BMI of 31. And then we can run another prediction, and we can say, let's see if the number of pregnancies that a person has had is a good indicator of diabetes or not. And you can see that, not surprisingly, because the numbers are so close here, it's not a good predictor, not surprisingly, right? So this is how we can use machine learning inside of Spark by using the notebook experience here inside of Azure Data Studio. So to wrap up, in summary, what we've built here is, first of all, a data virtualization platform that allows you to go and get data out of external data sources with caching, with parallel compute of those queries. We've built a shared data lake based on HDFS that you can access with either SQL or Spark. And we've built a complete AI platform that allows you to do everything from data ingestion to storing to training to scoring, all in one system. So your data never needs to leave the SQL Server 2019 Big Data Cluster to do your complete pipeline of AI. This week we announced that SQL Server 2019 went into public preview. The SQL Server 2019 Big Data Cluster is also in public preview, but we're going to gradually roll that part of it out to customers. So if you're interested in trying out the SQL Server 2019 Big Data Clusters, please go to this form here and sign up, and we will gradually roll it out to customers over the next few weeks. So thank you guys very much for stopping by. I'm here, people over here in the corner, they're also here to answer any questions that you might have as well. So thank you guys.